Welcome viewers. In this video we'll see the voltage and current division rule. First we'll see the voltage division rule. Here the two resistors are connected in series, R1 and R2, which is energized by the DC voltage V. So what will happen? This voltage, some of the voltage will be dropped across R1, some of the voltage will be dropped across R2. Depends upon the resistor value. Depends upon the resistor value, voltage will be dropped across R1 and R2. So the voltage across R1 is V1, voltage across R2 is V2. What is the value? The V equal to V1 plus V2. That is the first formula we need to say. The total voltage applied equal to sum of voltage drop across R1 and R2. Similarly, what is the current? The same current is flowing through R1 and R2. How will you find this V1? V1 equals nothing but current, that current I into R1. V equal to IR. So I is nothing but total current I, R is nothing but R1. Similarly, how will you find V2? V2 equal to I into R2. Based on that we can find. Now we'll see the description. In the series circuit act as a voltage divider. That is, since the same current is flowing through each resistor, voltage drop are proportional to the value of resistor. So the same current is flowing, but what about the voltage drop? That is depends upon the value of the resistor. So the series circuit means it is act as a voltage divider. Series circuit, the current is same, voltage will be dropped across that. So it is act as a, the termed as voltage divider. Using this principle, different voltages are obtained from a single source are called a voltage divider. That is, this V equal to sum of V1 and V2. Based on that, we'll go for the derivation. What is the total current? I equal to V by R1 plus R2. So this is the total current, that is equal to V by R. V is the applied voltage, R is two resistors available, so R1 plus R2. Right? Then what about V1? V equal to IR. I into R1. V1 means voltage across the resistor R1. So that I into R1. So in this, what is I? You can substitute the I value here. I is nothing but V divided by R1 plus R2 into R1. So this I value is substituted here. So that can be rewrite as V1 equal to R1 divided by R1 plus R2 into V. V1 equal to R1 divided by R1 plus R2 into V. What is this? Voltage across resistor R1 equal to total voltage multiplied by that resistor R1 divided by total resistor. So that is the general formula. The voltage drop across R1 equal to R1 value divided by total resistance into total voltage. From that is the formula. Similarly, V2 equal to I into R2. V2, what is V2? V2 is the voltage drop across resistor R2. So that is equal to I into R2. I is the same current, only one current into resistor. This I can be replaced with this value. I is nothing but V divided by R1 plus R2 into this R2. So R2 divided by R1 plus R2 into V. So voltage drop across the resistor R2 is nothing but the resistor value of R2 divided by total resistance into the applied voltage. Right? So from this we can see the general formula. Voltage drop across the interested branch. That is, which branch is called interested branch is branch resistance. Which resistor we need a voltage drop? That resistance divided by total resistance into applied voltage. Right? So this is the general formula. So voltage drop across interested resistor is nothing but branch resistance divided by total resistance multiplied by applied voltage. So based on that, we'll see one example. See, the two resistors are connected, 100 ohm and 15 ohm. Sorry, 10 ohm and 15 ohm. It is energized by the DC supply, 100 voltage DC supply. They take this 10 ohm as R1, 15 ohm as R2. The voltage drop across R1 is V1, R2 is V2. Now we need to find what is the value of V1 and what is the value of V2 based on the voltage divider rule. So what is the V1? Equal to total voltage, that is applied voltage, multiplied by the resistor value divided by total resistor, right? So that V1 equal to the total voltage applied is 100 multiplied by 10 ohm. The V1 is nothing but voltage across the 10 ohm. So 10 ohm. Which one we need voltage? That resistor divided by total resistor. 10 plus 15. 10 plus 15. Right? So 100 into 10 divided by 25. So this 4 times available. 4 into 10, 40 voltage. So the voltage drop across V1 is 40 voltage. So by using the voltage divider we calculated. Similarly V2. V2 equal to same thing. Total voltage multiplied by resistor of that voltage. Which one we need? That resistor divided by total resistor. So V2 is the voltage across resistor R2. So that here we need to use R2. So V2 equal to 100 into R2 value is 15 divided by 10 plus 15, that is equal to 100 into 15 by 25. So here 4 times. So 4 into 15, 60 voltage. So see this, the sum of these two is 100 voltage because the applied voltage is 100. So in that 40 voltage is dropped across 10 ohm resistor, 60 voltage dropped across 15 ohm resistor. So the less value of ohm, the less voltage will be dropped. For more value of resistor, more voltage is dropped. So sum of these two is the applied voltage. Now we'll go to the current divider rule. So the current division rule, you see that here two resistors are connected in parallel. The previous voltage divider rule, or the resistors are connected in series, then only the voltage will be dropped. For applying the current division rule, the current resistor should be connected in parallel, then only the current will be diverted. Right? So here the voltage V is applied, the total current is I. The two resistors are connected in parallel, R1 and R2. So what will happen? The current will be diverted through R1 and R2. We'll take this is I1, this is I2. So the total current I equal to I1 plus I2. Depends upon the resistor value. Sum of the current will diverted through R1, remaining current diverted to R2. So in parallel circuit, the current divides in all the branches. So the parallel circuit acts as a current divider. Previously the series circuit acts as a voltage divider. Here the parallel circuit acts as a current divider. So the total current I equal to I1 plus I2. That is a very basic formula. The total current entering into the parallel branches divided into branch current according to the resistor value. Based on the resistor value, the current will be divided. So we'll go for the derivation. So the basic thing is I equal to I1 plus I2. Total current equal to current flowing through the resistor I1 and I2. So I1 R1 equal to I2 R2 because the potential across both the resistors are equal. So in this diagram, the same voltage is applied through R1 as well as R2. So voltage across R1 is also V, voltage across R2 also V. Only the current is changes. So based on that we can write I1 R1 equal to I2 R2. So from that I2 equal to, bring this R2 here, I1 R1 divided by R2. So based on the voltage drop across both the resistors are equal, we formed this equation. From that we calculated I2. We know that I equal to I1 plus I2. In that you substitute this I2 here. This value is substituted here, so that I1 plus I1 R1 divided by R2. So this I2 is replaced by this value. Now take this I1 common. I1 is available in both the terms. So 1 plus R1 divided by R2. You take the LCM. So here nothing available, so this value will be multiplied here, R2 plus R1. So finally what we got, R2 I equal to I1 plus R1 plus R2. This R2 is multiplied here. This R2 is brought to the numerator. From that, how will you find I1? I1 equal to I into R2 divided by this value, R1 plus R2. I1 equal to I into R2 divided by R1 plus R2. That is, the current through the resistor R1 equal to total current multiplied by another branch resistor. This I1 is the current through R1 resistor. Another branch resistor is R2 divided by total resistor. Right? In case of voltage divider rule, same voltage, same resistor we are multiplying. Here, other branch resistor we are multiplying. That is the difference. So current through resistor R1 equal to total current multiplied by resistor of another branch R2 divided by R1 plus R2. Similarly, we can see the I2 value. So I2 equal to I into R1 divided by R1 plus R2. The current flowing through resistor R2 equal to I into other value of resistor R1 divided by R1 plus R2. So in general we can say current flowing through the interested branch equal to other branch resistor divided by total resistor multiplied by total current. Only here this will be changed. Other branch resistor. In case of voltage same branch resistor. Right? Now we'll go to we'll solve the problem. So in the first problem, the circuit is available. There are 3 resistors available, 2 ohm, 12 ohm and 6 ohm. From the diagram it is clear, these 12 ohm and 6 ohm are connected in parallel. The entire circuit is energized by 12 voltage. Right? So the total current is I ampere through the 2 ohm resistor. At this point the current is divided because of parallel circuit, current divided, I1, I2. So in this problem what we need to find the value of I1, I2. This total current flowing through this 12 ohm resistor and 6 ohm resistor. And this is it is marked as point A. This is point A, point B and point C. We need to find what is the voltage across 2 ohm resistor VAB. Then what is the voltage across B and C, this parallel combination. This voltage also we need to find. Right? So 3 resistors available out of 2 resistors connected in parallel. 12 voltage is applied. Total current is I. In parallel the current is divided I1 and I2. We need to find what is the total current, what is the current flow I1, I2, what is the voltage drop across AB and what is the voltage drop across BC. One by one we need to find. First we will simplify this diagram. So these two are connected in parallel. So we will find the equivalent resistance. So in this network 12 ohm and 6 ohm are connected in parallel. We will take this 12 ohm as R1, 6 ohm as R2. Then what is the formula for parallel combination? R equivalent equal to R1 R2 divided by R1 plus R2. R1 is 12 ohm, R2 is 6 ohm. So 12 into 6 divided by 12 plus 6. 72 by 18 is 4 ohm. Now this parallel combination is now converted into single equivalent resistor of 4 ohm. Right? So this 12 ohm and 6 ohm now converted into 4 ohm. Now circuit become very simpler. This 2 ohm and 4 ohm. We can easily see that these 2 and 4 ohm are connected in series. So we can easily find the other values. So the total current I equal to V by R. What is the V? 12 voltage. What is the R value? 2 plus 4. These two are connected in series, 2 plus 4. So 12 divided by 2 plus 4, 12 divided by 6 is 2 ampere. So we easily calculated the value of total current as 2 ampere. Right? I equal to V by R. All values are available. Now we can find the voltage drop across AB. What is the voltage V? V equal to IR, I into R. So VAB equal to I into RAB. So voltage drop across AB is nothing but current, total current into resistance across AB. So the total current is 2 ampere. The resistance across AB is nothing but 2 ohm. So 2 into 2, 4 voltage. Similarly, voltage across VBC equal to I into RBC. So I is 2 ampere. The resistor across BC, VNC is 4 ohm. So 2 into 4, 8 voltage. So 4 voltages drop across 2 ohm, 8 voltages drop across 4 ohm. The sum of these two, what is the sum? 4 plus 8, 12 voltage. So the 12 voltage, the applied voltage is 12. So the sum of these two also 12. So our answer is correct. Now total current is calculated. Voltage drop across AB, voltage drop across BC also calculated. Now we need to find the I1 and I2. The current flowing through 12 ohm and 6 ohm resistor. Right? So this diagram is drawn again. So this is a diagram what we discussed earlier. 12 voltage is applied. So we calculated the total current is 2 amperes. This 2 ohm and 12 ohm and 6 ohm. This parallel combination available. Now current is divided into I1 and I2. So now we need to find I1 and I2. Other values are calculated. So by using the voltage divider rule, we can find this current divider rule. We can find this I1 and I2. Right? So the total current is 2 ampere. That is divided into I1 and I2. How will you find I1? I1 equal to, what is the formula? Total current multiplied by other branch resistor divided by total resistor. So I1 is the current flowing through 12 ohm. What is the other ohm? Other branch current resistor? 6 ohm. So you have to multiply with 6. Right? So total current is 2 ampere. Other branch resistor is 6 ohm divided by total resistance 6 plus 12, 18. So 2 this divided by 3 times. So 2 divided by 3 ampere. The current flowing through I1 is 2 divided by 3 ampere. So current flowing through 12 ohm resistor I1 is nothing but total current multiplied by other branch resistor divided by total resistor. We need to use this formula. Similarly, current through 6 ohm resistor equal to total current multiplied by other branch resistor 12 divided by total resistance. So that is equal to 2 into 12 divided by 18. Right? So this got cancelled. This 2 and 18 got 9 times. This 9 and 4. This 9 and 12 got this 4 times is 3 times. So 4 by 3 amps. So the total current will be 4 by 3 amps. So if we add these two, we will get the total current of 2 ampere. So in the current division rule, we need to follow current in any branch equal to total current multiplied by other branch resistor divided by total resistor. Right? So in this problem, we calculated all the value. That is the total current, current flowing through 12 ohm, current flowing through 6 ohm, as well as voltage drop across AB and BC. These values are calculated. Now we'll go to the next problem. So in this problem, we need to find the current through the 10 ohm resistor. So there are 3 resistors available, 15 ohm, 5 ohm and 10 ohm. One current source is available, 5 ampere. So this 5 ampere, what will happen? The current will be diverted through 15 ohm, 5 ohm and 10 ohm resistor. Based on the resistor value, the current will be diverted. So in this problem, what we need to find? We need to find only the current through 10 ohm resistor. Right? Current through 10 ohm resistor is needed. But here 3 resistors available. If you want to find the current division rule, only 2 resistors are there. If it is 2 resistor, we will apply the current division rule. So in order to find this 10 ohm resistor, now we will simplify these two. These two are connected in series, connected in parallel. So we'll make it as single resistor. Based on the parallel combination, we'll make it as single resistor. That is 15 ohm and 5 ohm are connected in parallel. We'll take this 15 ohm as R1, 5 ohm as R2. What is the equivalent resistance? R1 into R2 divided by R1 plus R2. So R1 is 15, R2 is 5. 15 into 5 divided by 15 plus 5. That is 75 divided by 20, 3.75 ohm. Right? So now these two resistors connected in parallel, that is converted into single equivalent resistance, 3.75. Right? Now we can redraw this diagram. So this is a 3.75 ohm and this 10 ohm. Our aim is to find the current through this 10 ohm. See, now only two resistors are available. So we can easily apply the current division rule and we can find the current through this 10 ohm resistor. What is the current through this current through this 10 ohm resistor? I2 is termed as I2. That is equal to total current multiplied by other branch resistor. We need a current through 10 ohm resistor, mean we need to multiply with other branch resistor 3.75 divided by total resistance 3.75 plus 10. So I1 equal to total current is 5 into 3.75 divided by 13.75. So that is equal to 1.36 ampere. So current flowing through this 10 ohm resistor is 1.36 ampere. So in this problem, there are three resistors available. In that we need to find the current through this 10 ohm resistor. In order to apply the current rule, what we are doing, we are making these two as a single resistor because these two are connected in parallel. So that is make it as single resistor, that is 3.75. After making single resistor, we can easily identify the current through this either I1 or I2. We can easily calculate by using the current division rule. So in this problem, we calculated the current through the 10 ohm resistor. So in this video, we discuss about the voltage division rule, current division rule with the example, and we solved two problems based on both current and voltage division rule. Thank you.